Plants and trees are smart, but the modern world sees plants only as resources instead of as partners. And this has enormous consequences for our planet. Carbon emissions are warming the Earth, and trees are masters of storing that carbon safely in their bodies and in the ground. Yet many a tree planting project has failed, and I wanted to know why. And so I talked to a few people who taught me that plants can be more effective partners in saving this world, if we give them the respect they deserve. One of them is scientist and philosopher Paco Calvo, head of the Minimal Intelligence Lab, or MINT Lab, at the University of Murcia in Spain.
They are individuals with their own needs, their own will, their own subjective awareness, and if so, intrinsically, they deserve our respect, even if we didn't depend on them, even if we didn't breathe their oxygen.
And the other guest is one of his students, an experienced forest restoration expert and brilliant thinker of all things forests, who also turns out to be my wife, Anna Loy. This all started as a love story. Hi, I'm Charles Loy and I'm a filmmaker. A few years ago, I was busy building a career in film, but I wasn't making anything straight from the heart. And then I met somebody. And one day, we began talking about bringing new life into this world together. But then we talked about climate change. If we ever have a kid one day, I want to be able to look them in the eye and say, I did everything I could to ensure you grew up in a world worth living in. My friends and I made an Emmy-winning series on PBS called Climate California. What we found gave me hope. It's not too late. Climate change is solvable, whether it's by limiting warming or adapting to it. I talked to some of the visionaries who are leading the way, and they just might change how you see your role in this fight. So subscribe or follow from NorCal Public Media. This is A Fighting Chance. A Fighting Chance is a presentation of the Center for Environmental Reporting with financial support from the State of Claire-Etienne. Anna has been working on climate issues for a long time. In Germany, she started off as a Greenpeace volunteer. At Yale, she did a master's in forest management. And then in Beijing, she directed forest restoration projects across Asia. In old school forestry, trees are natural resources. We manage them for human-centric goals. How much money do they bring in? How do they help us? Instead of plant-centric goals. But plants are, after all, living beings with their own interests. And our lack of respect actually makes efforts to restore forests counterproductive. In 2020, Anna told me about a crazy idea. What if she quit her job and pursued a PhD to see if there's more to trees and forests than meets the eye? Wouldn't that change the world? So she went to Spain to study with Paco. And I'm glad she did, because I've never seen anyone love trees more than she does. And she just might help you see the forest for the trees, like she helped me. Hi.
Hi.
Hello.
Hi.
I have so many questions for you. Let's talk about the MINT Lab first.
The MINT Lab is one of the first labs studying plant intelligence, right? And that includes both like theoretical and practical aspects. So the theoretical work, right, we're technically in a philosophy department. This started off with Paco actually being a philosopher and then kind of branching into applied research. So we look a lot at the underlying principles or theories of cognition and if and how they could be applied to plants or different types of plants, right? I think a big criticism that the whole plant cognition field is facing is that it's not very rigorous, it has confirmation bias and so on. So Paco is actually very intent on replicating some of the earlier experiments that have been done. For instance, there is a very famous experiment by Gagliano that showed associative learning within pea plants. But we also do new and cool, looking at goal-directed or flexible movement within plants. This is partially what we're doing with vines. So we're seeing when you have, for instance, like a support structure, like a pole, vines try to find such a support structure. As they get closer to that pole, once they kind of like sense it, they like change the trajectory or they zero in more. So what I'm interested in is specifically trees, right? Or like woody perennials, long-lived woody perennials, right? So they can also be shrubs or something, because plants are inherently social. You very, very rarely find just like a lone plant like sitting around, especially in a forest. the sociality is kind of like the definition of the forest, right? So I'm both looking at like ideas of cognition applied to trees, but then also to forests, right? And actually, I'm currently working on a project that actively tries to build a framework for forest intelligence.
Yeah, you said something once in an interview where you said, imagine you're stuck in a place for 100 years next to your neighbors and you never talk to your neighbors. It's like if you and I like never talk to each other.
Exactly. Yeah, no, it's very odd when you look at like traditional forestry. It's dominated by theories of competition. We know that, for instance, a lot of trees, they do root grafting, right? Especially when they're close together. And root grafting means that the roots of two trees literally kind of like merge with each other. And these can either be like genetically identical individuals or genetically different individuals, usually from the same species. But the implication is if they actually kind of merge the roots together, they're sort of becoming one physiological individual and they're sharing resources. So it doesn't seem reasonable to say, okay, these trees are still competing with each other because they are now starting to be codependent.
You had a good metaphor about how if we held hands, we don't suddenly...
Should I hold your hand, dear?
Yes, I was trying to like find an excuse to do this. We don't merge into a single person, right? But like trees do.
Yeah. I mean, this has to do with ideas about individuality, right? And that makes plants like a lot harder for us to understand than like animals, right? So in animals, we have like this one single organism that's just like always themselves, right? That was what this example about the hand holding is about. We can't generally merge. We need to think about cognition in plants in plant-specific terms. So because animals cannot merge, right? They cannot actually graft together. This is not a dimension of sociality that we consider within animals, right? And thus, we don't have theories of sociality that include like the literal merging of two individuals. But in plants, especially in trees, this might actually be like a pretty big part of like how they behave and how they actually act socially. Plants have a stake and ability to influence their own communities, right? One of the things I'm, for instance, looking into is plants fundamentally are ecosystem engineers, right? So most of the soil we find on this earth has been created over thousands of years, of millions of years by plants, right? We know, I mean, if you've ever stepped into a forest, we know it's much cooler, much shadier, often much more moist. Forests are often great at retaining moisture and humidity, right? And so one of the things I'm looking into is how plants and trees are able to create the very conditions that are like conducive to their own survival. So they create their own climate, they create their own soil. I think this is like the kind of thing you don't really think about if you don't see plants as possible agents.
One of the reasons why we're talking to you is because the question for us is, what does this have to do with climate change?
When you think of plants as cognitive agents, you think of them as dealing with information and informational variables, right? That means that things that happen in the environment are inherently meaningful to plants. For a lot of plants, for instance, in order to leaf out, they need to hit like a certain minimum temperature in winter. This basically tells the plant, okay, winter actually happened, right? And like gives it like a point, okay, well, further along in the year. And then you have like different variables like, let's say, spring temperature or like a certain level of precipitation. We often don't have these minimum temperatures anymore. So the plants waiting for winter to happen, like the way they understand winter, right? And it doesn't happen. So that messes up a little bit the leafing out time. Also, a certain like a certain amount of days of warm temperatures, like let's say 10 days of warm temperature, historically used to mean there is a very small chance of late frost, right? Like spring frost. However, with climate change, we actually get like a lot more extremes. You get very, very cold periods of time again, and you get that late frost. And so when historically a week of warm weather would tell you that it's okay to come out, you're not gonna get frozen off. Now it actually doesn't anymore, right? And this can only, I think, be understood if you understand that plants take information rather than just mechanically responding to something.
Okay, but how does this help us deal with carbon sequestration?
Actually, it's a really good point to talk about like our obsession with carbon sequestration. Because currently, for instance, the way restoration projects are often done is you try to maximize the amount of carbon sequestered, which means often for us when we restore, we do it like kind of like in a, let's say, grid pattern, right? Because you just have them in like a nice spacing, they can all maximally grow up. When these trees grow up and they have nobody to kind of like merge with or cooperate with, that might make them less resilient. We run the risk that we basically, in a time where we have extreme amounts of change, actually create less resilient forests than even like a normal forest, right?
And the less resilient a forest from a climate person's perspective, the less they can sequester.
Or they just die, and if they die, the carbon goes back into the air, right? Like, so it's not just about like max amount of sequestration, but you want to keep it there. One of the issues that I ran into when I was still doing restoration work is that there were actually very low long-term survival rates in a lot of like these restored forests, right? So the way it practically works with a lot of restoration projects is they will measure this for the first, let's say, anywhere between 1 and 5 years, right? And so what they would often do is they would like kind of like plant them pretty far apart and then like water them, maximize like this short-term survival rate. But like if we go back there like 10 years later, you would actually have like a very high level of mortality, right? And part of the reason this might happen, and there's like studies that show this is actually called the stress gradient hypothesis. We know that like plants, when they're in very stressed environments, if you keep them close together, they actually have like facilitative, cooperative relationships, at least in a lot of cases, right? But that is like not what's usually done in forest restoration. You can think of it like from like a geological standpoint, right? In areas like very dry, right? And if they're like closer together, sometimes they can like capture the moisture in the soil better, right? And that like facilitates each other. So you end up with these restoration projects that like on paper have like restored something, or they were successful until the end of the project. But then you go back like 10, 15 years and they're just gone, right?
So plants are smart. They also need relationships. Climate change is making it more difficult to survive. They need to be able to survive together as a community. And if they die, then they can't store carbon and provide habitat. And this is why we need to remember that they're smart and respect them and their interests.
Yeah, that's more or less what I'm saying. I think one thing to point out is there are no universals, right? Just like we know with animals, some animals are more social, others are less. I'm sure a lot of people have heard of these warnings about the Amazon rainforest, right? And when we have a certain level of deforestation, it might entirely flip to a savanna state. That's what we call non-linear behavior. Why is this? It ties back to what I was saying partially with this ecosystem engineering stuff. The trees in the Amazon rainforest, or the Amazon rainforest itself, depending on how you want to define it, creates its own water cycle. It creates its own weather. You need a critical amount, a certain amount of trees in order to keep this weather pattern going. Once you remove enough of them, the entire system breaks down and switches into a new state, right? So with climate change, we're actually having one of the greatest changes at the fastest rate that the world has ever seen, right? So one of the issues I'm seeing in conservation is a lot of these like different protected areas or national parks, they're all fighting to keep the like the plant community, the forest and the species composition pretty much exactly the same, but that doesn't work anymore. And this is actually something we really need to address. We need to come up with conservation networks that we don't define by single species, but like by the overall structure of the conservation network, and allow species to actually dynamically migrate into new areas. I think in general, it would be good to leave forests a lot more to like their own devices, unless we have a principled reason to change them.
It's interesting too, the language that we use, invasive species.
Yeah, exactly. These invasive species, they're some of the smartest plants we have, because if a plant can withstand people and like all the crap we're trying to do to them, right, then that makes it a pretty resilient and adaptive species. But I think you need to have a very nuanced perception of like what invasiveness actually means, and whether we just stick to like old ideas of always wanting to keep it the same.
I hate nuance.
Yeah, I know.
When we come back, we talk to Anna's professor about how you go from paying attention to crafting science and theory that prove the skeptics wrong. If you're listening to this podcast, we do have a lovely video version. You can watch it or listen to it wherever you get your podcasts. I hope you do become a member of NorCal Public Media. For as little as the cost of 2 lattes, you can sustain public media and give us a fighting chance at season 2. Go to norcalpublicmedia.org/donate. Thanks.
I've been hearing for decades that the markets can solve climate change. Today, we have more incentives for market solutions than ever, and emissions are rising. On this season of Drilled, Carbon Cowboys, the story of 3 market solutions colliding in one multinational boondoggle.
You gotta give Bruce and the guys credit. They're Republicans. They don't give a shit about any of this stuff.
Listen anywhere you get podcasts.
And now our conversation with Paco Calvo. How did you get into plants?
Oh my God, that's a great question. Once upon a time, I used to be a straight philosopher, and I was interested in the human mind. At some point, like we are talking like 25 plus years ago, I moved to San Diego, UCSD, and we were working, in artificial neural networks. And surprise, surprise, what's the closest you can get to an artificial neural network? Plants, right? So they are fully decentralized, no central nervous system, nobody sitting there at the wheel doing the driving. So to me, the next stage is to operationalize, to make crystal clear the type of question we can be raising to measure plant intelligence, to measure plants' degrees of sentience. What does their intelligence and their subjective awareness consist of?
We've been spending a lot of time with people who care a lot about redwoods. What is it like to be a redwood?
Well, that's a great question. Actually, I cannot know, you see? And that's a good question, because this allows us to understand why the challenge is so big. If you want to understand what is it like to be a redwood, first thing you need to do is to forget about the redwood itself and look around it. What does the world look like from its perspective? It's not what's within the organism, but how the organism interacts with the surroundings. So you might need to check what's happening in the vicinity of this forest, or that tree in particular, to try to make sense of what is it that they would be caring about. On top of exhibiting adaptive behavior, which they would have gone extinct a long time ago, they need to be doing something else that has to do with individual. What is it that individual has been exposed to that has altered their behavior? So their behavior won't be just adaptive, but it's got to be flexible enough, as we say happens, right? Things might go wrong. They need to be ready to change gear. And that requires flexibility, not just following a routine that comes in your genes. They've got to behave anticipatorily. So they've got to foresee possibilities ahead of time. Because you see, plants and trees are damn slow. We know that. That's why in our lab we time-lapse them, right? We need to speed them up to be able to appreciate their doings. But by the same token, because they are so slow, it does pay off for them to foresee, to anticipate. Otherwise, they are simply catching up. They need to learn, they need to connect the dots. They are individuals with their own needs, their own will, their own subjective awareness, and if so, intrinsically, they deserve our respect, even if we didn't depend on them, even if we didn't breathe their oxygen. So it's respect because of their individual essence, not just because we need them.
You talked about how they learn, right? But they need time to learn. Are you worried about
absolutely.
what climate change is doing, because so much change is happening so quickly?
Well, certainly, that's an issue, the time scale, right? So certainly we are not ready for what's coming, because the speed of change, the rate of change is far too fast. And any form of life whatsoever is struggling to catch up. We truly need to think outside the box. And thinking outside the box requires to rethink root and branch the whole problem.
You wrote in the book that plants are active participants. They're not just passive tools.
Absolutely. Think about it. Even in the case of domestication, remember in the book at some point I speak of the difference in between wild plants and domesticated plants. And I spoke of different degrees of intelligence. The ones we've domesticated, they've become, like a spoiled child, spoiled children. We provide them with food, nutrients, water, whatever. They feel so comfy. They don't need to think hard. We give them everything to them as we do to our children, right? But this is funny, because this idea of domestication, we only apply it to them as if it was us domesticating them. And we don't realize that this is a pattern of coevolution. Any form of life whatsoever is co-evolving with the others that they are interacting with. So in the very same way that the flower and a pollinator You cannot be thinking of the smarts of the pollinator, which we always do, because we have this animal-centric perspective. So we just think of the pollinator being like the smart guy, and the flower sitting there. Oh, lucky me, a pollinator came around, right? Now we know that the flowers are really pulling the threads, right? They're really the ones in charge, right? Or I should say they are both in charge, because this is an emergent pattern of coevolution. Now the same thing holds for us. We are both on stage, co-evolving and shaping each other.
How do you deal with the skeptics?
How much time do we have? Sometimes I deal with them by counting to 10, like to 10 million, I mean, because you've got to be so patient. I mean, it's just amazing. My real worry is not the skepticism. I mean, we have got to be a skeptic. Let's just do the science. Let's gather the evidence. And the more evidence we have, the more robust it is, the better. You know, when I give a talk, Planta Sapiens, Plant Intelligence, very first question, people will say, hey, you ruined my life. I'm a vegan, I'm a vegetarian, now what? You are telling me plants are sentient, they are intelligent, they can be stressed, now what? What am I supposed to feed them, right? So to me, if that is the reaction to the main thesis of my book, or the discourse on plant intelligence, there is something we are still not getting. Because by thinking in those terms, we are still thinking in terms of abstract categories, like the kingdom animal or the kingdom plants, as if kingdoms themselves existed. Those are abstractions. That's a way of speaking. They don't exist. We need to be thinking of the individual. So remember the idea of coevolution and domestication. So by domesticating them, we are doing the very same thing we have done with animals. If we understand our relation to plants as a relation of subordination, we will never get it. Yeah. That's what I mean about understanding the relation as a relation that is horizontal. We are all on the same page. Nobody is providing any gold standard to anybody else. Different problems, different solutions. Plants have their own problems, they bring up their own solutions. In fact, even Charles, when you mentioned way back about how slow they are, right? Mm-hmm. In truth, they are not slow. If you think they are slow, it's because you're still thinking, if only implicitly, that they need to be compared to fast creatures. They are neither fast nor slow. They are well adapted to the stuff they need to be doing. And they don't need to go shopping because they make up their own food through photosynthesis. So they might say, hey, if you say they are sessile, they cannot be intelligent because they are sessile, they are rooted, simply sitting there. They might say, no, you are the one who is stupid that need to go shopping and need to move fast. I don't need to move fast. So let's stop making comparisons, and then we will realize that things are neither slow nor fast. Things are neither more intelligent or less intelligent. They are simply doing whatever they need to be doing, given their problems they have. Their own problems, not yours.
I love that. Yeah, Redwood doesn't have Charles's problems or Paco's problems.
Definitely.
Why do you like trees?
I mean, to be honest, I think they're way cooler than people. No, I think they're so interesting because they're so different, you know? I think somebody said before, like, the real aliens on Earth are plants, right? I think we can learn a lot about, like, how amazing and weird and diverse life is just looking at plants. They do all kinds of things that like are impossible for us. Trees are amazing architects. Actually, if you often look at the static stresses that like a tree with its ever-evolving crown actually faces, like you would need like an engineering degree in architecture to even envision something remotely like what a tree is able to achieve. So, yeah.
It's a little bit like a skyscraper that's like continually growing and doing stuff and not just standing there.
Exactly.
Do you ever go to them for therapy or for something that you need?
It says something very specific about like people going into the forest wanting something versus people going into the forest to co-experience or to have the curiosity about another living being. I think we focus way too much on like what plants and trees can give us versus like how we can share the world with them, you know?
Last question. Do you have any feedback for me?
Yeah, stop slouching.
Anything else?
Stay cute. Stay cute. I love you.
You can see Paco Calvo in episode 3 of our Emmy-winning series, Climate California. That's the episode that Anna and I co-wrote. Watch it on YouTube, pbs.org, or your local PBS station. Thanks for joining us. If you enjoyed the show, make sure to follow or subscribe so you don't miss an episode. And in the meantime, connect with us on social media. Until next time, maybe go make friends with a tree of your choice. A Fighting Chance is a production of NorCal Public Media's Center for Environmental Reporting. This episode is produced by senior producer and editor Taylor Kaufman, executive producers Darren Lachelle and Nathan Toby, and me, Charles Loy. It's edited by Jennifer D. Filippo and myself, and filmed by Clara Carbajo, Michael Field, Hannah Lee, Jeremy Ju, Anna Loy, and Brittany Hernandez. Original music by Miguel Brierly. Talent booking and marketing support by Jessica Pilot, Kristen Hayford, and Shemay Saunders. Artwork by Ashley Wittenborn with photography by Michael Field. Our digital content manager is Kelly Olson. Our head of TV is Paul Swenson. For full list of credits, go to afightingchancepod.org.